And so this is time rates. So for example, we have a quantity x, and differentiating this quantity x as with respect to time, let's say dt, that is the time rate of change of x with respect to time. So if we are solving time rates problem here in differential calculus, that is the same as small change with respect to time. Alright, so we are, when it comes to time rates, here in differential calculus, we are encountering again worded problems. So again, don't forget the steps. Identify what are the given. Okay, so what are the given? Then what is required? What is required? Then you need to set up your equation. So set up your equation or equations. Then, okay, if you have the equations, perform differentiation. So we are to differentiate these equations. Then lastly, the last part, we are to substitute. It's either substitute the values from the differentiate equation or the given. Okay? So let's have an example. As example, okay, two sides of a triangle measure 15 meters and 20 meters. When the included angle is 60 degrees, it increases at the rate of 1.50 degrees per second. How fast is the area of the triangle increasing? So we need to identify the given. Okay, so our given is we have a triangle. Okay, according to the problem, okay, one side is 15 meters, the other side is 20 meters. So when the included angle is the angle between the two given sides. So this is, we have 60 degrees, or this, let's say this is theta. And we have theta. The value of theta is equal to, given is 60 degrees. So when the included angle is 60 degrees, it increases at the rate of 1.5 degrees per second. So we express that the change in angle, or the change of the angle with respect to time. So this is time rate. So the change in, or the increase, or rate of increase of the angle with respect to time is given as 1.50 degree per second. So how fast is the area of the triangle increasing? So we are looking for how fast is the area of the triangle increasing. So how do we express the area? This is differential area increasing with respect to time, that is dA over dt. So gaano kabilis mag-increase yung area nito kung ito nag-i-increase siya? So which means this is opening at the rate of 1.5 degrees, or this angle is spreading at the rate of 1.5 degrees per second. If that is the rate of the increase of the angle, which means the area is also increasing. Lumalaki rin yung area. Kaya lang, at what rate? That is differential area divided by differential time. So those are the given. This is the required. The change of area with respect to time. We need to set up our equation. Okay, so equation, how to compute for the area of a triangle if two sides are given and the angle included is also given. So let's say this is side A and side B. If you are to recall, from your geometry, how to compute for the area of a triangle having two sides and an included angle, that is 1/2 the product of the two sides, say side A and side B, then sine of the angle included. So that will be the equation. So we have now the equation. What is that? That is, identify the given. This is the required. We have the equation. What is the next step? Differentiation. So differentiate, but this time we are to differentiate both sides of the equation with respect to time. So this is derivative of area with respect to time, differential area with respect to time is equal to 1/2 AB. Take note that sides A and B are constants. So this is, ang nagbabago lang, di ba, constant si A and B, hindi magbabago yung sides na yan. Ang nagbabago lang is yung angle. So this is, the sin theta is the variable. So what is the derivative of sin theta? Derivative of sin theta is, we have cosine of theta, then derivative of the angle is the same as d theta over dt. If you are to recall, what is the derivative of sine? The derivative of sine x, that is the same as cosine x dx. Kaya lang dito, ang variable natin, we use the variable theta this time. So cosine of theta, d theta, but with respect to time. Since we are in time rates. So that is the equivalent, the first derivative of this equation. So tapos na yung differentiation. What is the last step? We are to substitute. So we have the differential area divided by differential time is equal to 1/2. What is the value of A? That is 15 meters. The value of A is equal to 15 meters. We have the value of B. This is 20 meters. Then we have cosine. What is the value of the angle theta? Cosine theta is, we have 60 degrees. This is cosine of 60 degrees. What is the value of d theta over dt? That is the rate of increase of the angle. Given siya as 1 point. This is 1.5 degrees. This is 1.5 degrees per second. Pero take note that we should express the degree into radian. Okay? So we need to express the 1.5 degrees into radian. And never mind this one since we have the trigonometric function. So it's 1.5 degrees. This is multiplied by, we have 2 pi rad is to, or that is the same as pi radian. We have pi radian divided by 180 degrees. So that will be the equivalent of the rate of change of the area with respect to time. So let's compute. So the area is increasing or changing at the rate of 1.963. Take note, this is meter, square meter per second. Take note that radian unit is the same as unitless. So it's the rate of change of the area. So next example natin. So let's try change in volume naman. So water is pouring in a conical tank at the rate of 8 cubic meter per second. So cubic unit with respect to time, that is differential volume over time. If the height of the cone is 12 meters and the radius of its circular opening is 6 meters, okay, how fast is the water level rising when the water is 4 meters deep? Ito. So obviously, if we are adding volume to this, volume of water to this container, obviously the water level will rise. So let's say this is the change in height of water with respect to time. So the current height is 4 meters, dimension of the cone 6 and 12. The change in volume or the volume pouring into the conical vessel is 8 cubic meter per minute. So those are the given and we are able to identify the required. So what's next? After identifying the given, after identifying the required, okay, the third part is we set up our equation. So usually, when it comes to calculus, it is very important that you can recall all your basic mathematics or geometry, algebra, and so trigonometry. Okay? So since we are dealing with volume, what is the formula for volume of a cone? The volume of the cone is equal to 1/3 of pi, the radius squared times the height. That is the volume of a cone. So we are looking for the change in height of water as we increase the volume. Okay, so the volume is variable, nagbabago yung volume niya. The height is also variable since we are adding water, the water level rises. How about yung radius? So the radius, okay, so the radius is also increasing per surface of water. So initially, ito yung surface ng tubig, pero as we add water, this surface of water will increase up to 6 meters. So which means that is also a variable. So you need to identify which is a variable or a constant in a given equation. So what should we do if we have two variables? So usually here, you need to express one variable in terms of the other. Or usually for time rates, dapat isa lang yung variable mo. You have one variable per side of the equation. So we have one variable on the left side, two variables on the right side. We need to express R in terms of the H since dH over dt yung unknown. So if we are to create triangle, so usually we need to we use similar triangles here in cone. So we have the height of 6 meters. The height of this triangle is, or the height of the cone is 12 meters. So let's say at a certain value of R and a certain value of H, since they are both variables. So variation proportion, this is R is to H, is the same. R is to H is the same as 6 is to 12. So we are expressing the radius in terms of the in terms of the height, that is by 1/2 of H. So we need to substitute this value in this equation, then perform differentiation. So we have the volume is equal to 1/3 pi. What is the equivalent of the radius in terms of the height? That is equal to 1/2 of H. Okay, take note, that is squared times H. So the volume is equal to 1/3 pi. This is the same as 1/4 H squared times H. Or simplifying further, and we have this is 1/12 pi H raised to 3. So we have now one variable on the left side, one variable on the right side. We may now perform differentiation. Step number 4. So we have this is the change in volume with respect to time is equal to 1/12 pi. These are constants. We have this is 3h power rule, 3h squared. Okay, this is the change in height with respect to time. Okay, and the last step, after differentiation, the last step is we have to do substitution. Okay, so by substitution, what is our differential volume? That is 8 cubic meter per second. This is equal to 1/12 pi. This is multiplied by 3 times. So we are looking for the change of height with respect to time at h is equal to 4. So it's the same as 3 times 4 squared. We are looking for dh over dt. Okay, so let us compute for the differential height with respect to the change in time. That will be equal to this will be equal to 0.637 meter per minute. If you have to do unit analysis, that will be meter per minute. So as we increase the volume at the rate of 8 cubic meter per minute, the water level rises at the rate of 0.637 meter per minute.